This is lesson 2-4, which is about the slopes of parallel and perpendicular lines. Your I can statement is I can use slope to solve problems about parallel and perpendicular lines. Before we can jump into this example, we need to review a couple things, and I want you to do that on your model and discuss page. I want to review that slope is the difference in the quotient of the rise, the vertical or positive or negative rise up or down over the run to the right. So if it is negative, that means it's going down and to the right. If it is positive, that means it's going up and to the right. And you can calculate that using our slope formula. I also want to review that an equation of a line can be written in slope-intercept form. This is not the only form, but it is the form we are going to be using for this section, which is y equals mx plus b, where m is the slope and b is the y-intercept that represents where that line crosses the y-axis. We need to review both of those things. And now we can turn the page, and where you have room, and for example 1, I actually want you to pause and write theorem 2-13, which is essentially telling us that lines are parallel if and only if their slopes are equal. We're going to use that right now in example 2. So example 2 gives us this figure. You do not need to write the figure down. You just need to be using the information from it. And it asks you, are lines M and Q parallel? And so out to the left, I've given us steps that you can take notes on. Well, we will first find the slope of both lines, step 1 and 2, find the slope of the lines. And then 3, we will compare them. Because what we are learning that is if they are parallel, the slope should be the same. All right, so let's do step 1 and find the slope of the first line of line M. So step 1, we'll find the slope of line M, and we use M to represent slope. So this is line M, and we're finding the slope. And we want to do the y sub 2 minus the y sub 1. So I'll do 3 minus 4. And I'm going to put that over the x sub 2 minus the x sub 1, which is negative 4 minus negative 1. I'm going to literally write it like that, negative 4 minus negative 1. And now I can calculate that, and I get negative 1 over negative 3, which a negative divided by a negative leaves me with a positive 1/3 is the slope of line M, which means we go up 1 and over 3. Now step 2, we want to find the slope of line Q, and I still use M to represent slope. I just know that I'm now dealing with the second line. And once again, I want to do y2 minus y1, so that is 0 minus negative 2 over x2 minus x1, which would be 1 minus negative 4. And I'm going to simplify that numerator and denominator, and that leaves me with 2 over 5. So we have found the slope of the first line to be 1/3. We have found the slope of the second line to be 2/5. And the problem asks us, are the lines parallel? So our third step is just to actually compare them, and they are different slopes, so that means they are not parallel. So no, we are not parallel. These are different slopes. They cannot be parallel lines. All right. Let's move on to example 3, which we're going to start talking about some perpendicular lines. And in the space to the left, we're going to write theorem 2-14, which tells us that if two non-vertical lines are perpendicular, if and only if the product of their slopes is negative 1. And you might have learned this as Algebra 1 with the words opposite reciprocal. Opposite reciprocal, which just means they have opposite signs. So one is positive, the other is negative, and it looks like a flipped fraction. And an example I gave you is 2 and negative 1/2. So we know secretly that's 2 over 1. So we will know that the lines are perpendicular if their slopes are opposite reciprocals. And that means that when you multiply them together, their product is negative 1. So we're going to do 3a, and again I have a figure for you, but I have written down the points that they go through, so you do not need to write down the figure. You can just write down the points that they go through. And we're going to find the slopes of both of those lines. So we want to find the slope of h first, and the slope of that is going to be, I'm going to do the y sub 2 minus y sub 1, and I'm not going to color coordinate it this time. That'd just be negative 1 minus negative 3 over negative 2 minus 1. The slope of the first line is 2 over 3. 2 over negative 3, sorry. 2 and negative 2 minus 1 is negative 3. All right, the slope of the second line is 2 minus negative 3 over 3 minus 1. And 2 minus negative 3 is 5, and 3 minus 1 is 2. And what we can see is that these aren't opposite reciprocals, but let's prove it. 2 over negative 3 times 5/2 does not equal negative 1. They are not perpendicular. If those were perfect opposite reciprocals, their slope would multiply to be negative 1, and it does not. So they are not perpendicular. You're going to try this next one, and I'm going to change the problem a little bit. So I'm going to make this to where you can see the 2 points. I want you to do line K and line J. So your book does not say J. I want you to mark it out, and I want you to do J. And I've given you the points that those lines go through. Pause, find their slopes, and determine, are they opposite reciprocals? All right, so let's see what we did. So the slope of line K should have been 2/3. The slope of line J should have been negative 3 over 2. And for what we can see here is those do look like flip fractions with opposite signs. So when we go to multiply them, 2/3 times negative 3 over 2 does equal negative 1, which means yes, they are perpendicular lines. Again, opposite reciprocal just means opposite sign, positive or negative, one of each, and a flipped fraction. Let's go into our last example. We're actually going to start writing equations of parallel and perpendicular lines. I've changed the directions a little bit because the directions say, what are the equations of lines parallel and perpendicular to the given line? So it wanted us to do both parallel and perpendicular for both examples, and we're not going to do that. We're just going to write perpendicular, find the perpendicular line for the part A, and we'll find the parallel line for part B that you'll try. So I've given us some steps here that we can always follow. The first step is going to be to identify the slope of the line we're trying to write. So they give us the equation y equals negative 3x plus 2, and we want to find the line perpendicular to that line that goes through the point T, which is located at 3, 1, when x is 3 and y is 1. So we want to find the perpendicular line, which means I'm going to first identify my given slope, and I was given that m equals negative 3, and I just pulled that from that slope-intercept form. And now I want to write the perpendicular slope. So if I want to write the perpendicular slope, m is going to equal, I'm going to flip that fraction, so now it's going to be 1/3. And it was positive, so I want it to be negative. So that is a positive 1/3 would be my perpendicular slope. Now my next step is I'm going to find the y-intercept, and I'm going to use the point they gave me. So use the point. And I start in slope-intercept form, which is y equals mx plus b. I now know my m is 1/3. Got that. And I'm going to substitute the x and the y from the point that was given to me, 3, 1, where x is 3, so where I see an x, I'm going to put a 3, and y is 1, so where I see a y, I'm going to put a 1. And then I still have that plus b, because that's what I actually want to find, is that y-intercept. So if I do that, I will bring this equation down. I'll have 1 equals 1/3 times 3 is actually 1, plus b, subtract 1 from both sides. It just so happens those both have to be 0. So my y-intercept is actually 0, which means I don't have a y-intercept. It's at the origin. And my third step is to use that y-intercept to write the equation with that slope. So again, I want to use the form y equals mx plus b, and I'm going to sub my m and sub my b. So when I do that, y equals, I know my slope is 1/3. And again, I'm writing an equation of a line, so I should still have the x and the y. And I actually didn't have a b value. My b value was 0, so I could write plus 0, but we also know that if we are adding 0, that does not change anything. So I don't need it there. And I can leave it as y equals 1/3 x is the equation of the perpendicular line that is perpendicular to this line that goes through this point T. All right, you guys are going to use these 3 steps to find the equation of the line that is parallel to the given line in part B and goes through the point 12, -2. All right, if you did that with step 1, you want to find the slope. If you want parallel, the slope should be the same, so it should be 3/4. Then use that point in that slope to find a b value. Your b value, y-intercept, should be -11. And when you put that all together, the equation of the line should be y equals 3/4 x minus 11. How'd you do? Awesome. And this is section 2.4, parallel and perpendicular lines.